it's a personal thing, is that I think there can go a lot, like a lot of things can go wrong on the way if you're not 100% sure what you're doing. And then I would be super afraid that I have a wrong data set in the end. But that's maybe just a personal thing.
Yes, but this is the typical, you know, inverse engineering that every time you have to find to figure out if you're what, because maybe you don't have syntax error, you get the output, but it's wrong. Okay.
Yeah.
So this kind of, for example, the one that I went back in the graph and the graph, whenever I do some matching new stuff, let's say, I'm not 100% sure, I try to do it manually for few files and see if I get it. Anyway, if you do this, you know, print number, column number 1, 2, and so on, you have to be careful that, you know, the default in Linux is space. Okay, so for example, so for example, over here, you know, the river, yeah, you can have a river name that has 2 words. So if you say print column number 1, 2, 3, and 4, you are not getting the full name of the river, you know, because for some river, yes, but in this case, you will get just this. You will not get all this one. So what you can do is, for example, in this situation, you can use the 2 dots as a separator. So in this case, you can do, okay, so you can do grep. Okay, first of all, grep river. Okay, so it's giving to me this line, and then you can say, okay, awk, and this is a good example, awk, and you can say dash f, and you say 2 dots, probably you need quotations here, be sure, and then you say print. So in this case, you will have, this one is going to be your first column, and this is going to be your second column. So print $2 is going to give you just the river name. Rather, if we were doing, you know, without this one, and maybe put it 1, 2, 3, and 4, you will get only the river and not, you know, and not the full name. So this is the kind of error that you can encounter if you don't do it properly. So, but again, with a bit of double check, you don't need many lines of nowadays. If you have, you know, print number, so some if condition in the beginning, if $1 is bigger than whatever, then are more than enough, you know, and then you buy something else are more enough for shrinking your data, exploring, and so on. Okay, very good, Alex. And also, this is again awk and bash, and sorry, or bash directly as it is with unique, sort, join, head, less, more are working for text file. Okay, so whatever you can open with an editor it means that is a text file. So rather, whatever you have, other kind of file like TIFF, NetCDF, database, DB, and so on, you will need binary software. And today Lonzo is going to explain you very well about this numerical system that has been changed through the age of the years until we arrive to the binary for the computer system and so on. Okay. Any other question, little question, let's say, or even long? I mean, it's not. If not, we can migrate to the second part of the lecture. So keep play with this. These are nice data set if you download it, and keep it play because it's very useful for this kind of text manipulation. You can really appreciate the value of the OG. And then we will see also, for example, okay, you get the X and Y coordinates. We plot it, for example, new plot, but you can also convert to shapefile. And we will see later on with PK tools. So now the new part of the lecture is going to be the GDAL part. So now if you enter in the virtual machine, I hope that it's not getting, sometimes getting stuck, okay. Like usual, we are going to address it, the GDAL, so you can go in the docs, actually not in the docs, in the Jupyter lab. So we are going to enter like usual in the SE data, then do git clone, sorry, not git clone, git pull, pulling. Okay, we have been done a lot of update and so on, so we get quite a lot new stuff coming. And then you can do the rsync. If you do Control R and then RSY, you should have already the line inside to your terminal. If not, like always, you can go to the first page, and you can find in the OSGeo live. So if you go to the typical page, yes, it's coming. So in this one, it's your for yes, in the OSGeo live for spatial ecology courses, and you go down here, you have that line over here. But again, if you do Control R, and you type, you should have, you did so many times, it should be already your map. Okay, cool. So then whenever you are here, then you can, as usual, migrate inside to the MySC data, we migrate inside exercise, and we are here. So when we are here, we are going to open, so you know, Jupyter Lab, and we are going to open, I use double tab to list it, and we are going to use the GDAL OSGeo. Be careful, do not open the collab OSGeo. Okay, so at this point, you can, is opening the Jupyter Lab. Okay, so meanwhile that is opening, I also open the GDAL.org that we are going to address it now. So you will have the Jupyter Lab that is opening, I hope so, and the GDAL for the GDAL page. So in particular, probably many of you, or let's say most of you, are already using GDAL. So let me see who is using. Use the hands, the little hands in the over here. You can have the little hands, and this way we can count. Which one? Rotation. Yeah, one, Alex, somebody else. Okay, so two. Okay, so probably Mariano also. Maybe you're not finding a little hand, but he's using this. Okay, good. Okay, so we have a couple of them that are using. So GDAL stay for Geographical Data Abstraction Library, and is part of the Open Source Geospatial Foundation. So it's really the backbone and really the AV engine for all the GIS software. Okay, so all the GIS software and remote sensing software too, they are using GDAL in their backbone. So even if you don't know, ArcGIS, ERDAS, QGIS are using GDAL for the main operation in the raster and vector environment. So GDAL allow the talking and the conversion between the different formats. So you can go from TIFF to NetCDF to ArcInfo, old ArcInfo, ASCII file, and modern HDF, for example, HDF for Landsat and so on. So you have all the different raster format and also the vector format conversion, like from shapefile to JSON, from shapefile to SQLite vector. And I think everybody knows the difference between raster and vector. Anyway, always think that raster is a big matrix and vector are nothing else that can be lines, points, or polygons. Okay, so these are the two main way of graphical interpretation in the raster environment. but not sorry, the GIS environment, but not only the GIS environment, also in other kind of graphical operation. And what I mean, for example, when you take a picture with your mobile or with your camera, you have a raster feature with the RGB value that you can see the color. When you use GIMP, for example, you working in the raster environment. So rather, Inkscape is another software for vector environment that are really ending for making nice plot and maybe adjusting a bit some plot that are coming from R that is very tedious in some setting. So Inkscape is very good for this kind of vector analysis. AutoCAD, for example, is another vector software. So you can always find, let's say, the vector and raster principle also in software that are not really GIS. Okay, so but they have the same common terminology and way of treating the data. So over here, if you scrolling down, you can see immediately the two big raster and vector drivers. So in the raster drivers, and for the drivers, you have the different format. So as you can see, you can find all of them. Some I really never use it and never even heard. So the most common that I use it is NetCDF, HDF, TIFF. Yeah, some S3 file sometimes, but really rare, maybe in the past. JPEG 2000 now, for example, with all the Sentinel. But these are the most common one. And of course, with GDAL, you can migrate and change format. Okay, so all these format are binary format. Apart, some of them that can be also text. We will see a nice application. And so here you have a nice list. You can, for example, if you go into the TIFF, this is a new one, for example, the cloud optimized GeoTIFF generator. This is really has been built less than 1 year ago and is very good for creating TIFF that they have a fast rendering into the WebGIS. So I was preparing some data for a WebGIS platform and I was using this cloud optimized GeoTIFF generator. So Lonzo, over here you can read some specification that the other day you were asking me. So the GeoTIFF is really one of the most important file nowadays that is open source, so there is no property behind. You have a lot of information over here in the GeoTIFF, and this is growing. So and quite often I also go there and find a new flag that you can use it inside GDAL to have better compression, to have tiles inside to the GeoTIFF, overview inside to the GeoTIFF. So it's really getting um, um, getting more and more. And over here, for example, you have several metadata or at least flag information that you can use it for the different kind of application. Again, we will see some of them for sometimes also for me are quite new because they keep updating. I will explain very well the no data value that quite often is making the people a bit confused. And all the different create option for inserting compression, file, for example, bigger than 4 giga, is going to be somewhere over here, because they have the GeoTIFF has this internal limitation that cannot be, as a default, cannot be more than 4 giga. So if you want something bigger than 4 giga, you have to allow this large TIFF flag that it can go over the 4 giga. So can happen. Usually, I always say try not to produce file bigger than 1 giga, because if not, it's very first you cannot opening, you cannot see what is going on, and they are very difficult to load it. And we will see different operation that we can do it for tiling the raster file. But there are some cases like project that I'm doing now that I have to create larger file, and some of them they are 4 or 5 gigas. So I use it this function. Actually, we can Google it. You can search is big. No, I think it's large. No, big. Yeah, big TIFF, this one. Okay. So over here you can, and there is an option. Oh, maybe it's large TIFF. Yeah, okay, so this is the large TIFF, 4 gigabytes. They, as a default, you cannot support it. So remember, and actually GDAL is coming out if your file is going to be bigger than 4 gig. What else? You have the same kind of structure for the vector drivers, the vector format, and the same here you can go for the AutoCAD DVG file to the typical shape file, JSON. Now JSON and are very common. There is also these spatial light or SQLite format that is also quite handy. I still use the shape file because it's very easy to open inside OpenEV. But there is another one, the SQLite, that is very nice because it's only one file. And then people spatial light, and also people that are using R, they're in the last years they are using the, I think, the GPK, yes, geopackage vector, and the GPKG can be for both, for vector and raster file. So people that later on want to import a file inside R in a, they say that it's faster. I never check if it's true or not. So they can produce JPKG file that they can use and import it. Okay, perfect. So this kind of two division between raster and vector file, you can also find inside to the to the programs, so to the command line. So you have two main block raster program that are dealing with raster, with the matrix. Then you have the vector programs also that are dealing with the vector files. But then they come up also these in the last 2 years, this other section, let's say, where you can have multiple dimensional raster. So in other words, they call it the so-called data cube, where you have different TIFF, and you have not only the spatial dimension, but you have also the time dimension. This is coming quite quite fancy for the quite often common for the data cube iteration. There are several software that are dealing and try to dealing with the data cube. So for example, R has been developing in the last 2 years, the Terra. I don't know if somebody else been using the Terra library. So it should be much faster than the raster library. So it's the new raster library. So I don't know, somebody has been using. I think Alex will say yes. So do you think it's faster than the?
No, actually, I never used it myself. Julia told me about it, but
Okay.
I realized that raster is getting extremely slow when you get bigger rasters, and it's been annoying me a lot.
Perfect. Yes. So we will see all these applications with GDAL. So Terra, they say to me, maybe Julia can say something, that they are getting faster, but frankly speaking, I don't believe it's faster than GDAL applicators. So we can make some comparison. Julia, you want to say?
Yeah, I started using it recently, but for my task that I was doing now, PK Tools was the better solution. So I haven't used it that much, but yeah, I will. Yeah, probably for some things I will probably use PK Tools.
Yeah. So with this software, with the GDAL and PK Tools, you can do 99% of the raster operation that you want to do it. Okay, and also with the vector, you can do quite a lot. I really use it for daily life continuously under the bash environment. They have also application to import it inside Python as a library. Probably Lonzu is going to show you some application with the geo package. I don't really do it because there is GDAL tools that are already binary format under C environment that I can call from bash. So why reinventing the wheel and spending time in building up, you know, tools that in Python that does operation between matrix, okay? So this kind of application, you really enter inside Python when you have to do it, something that you don't find, for example, what you cannot find, or some fitting a spline in only in the diagonal pixel y direction, you know, something very, very particular that you so in that case, you need to enter in Python, and you need to play with a NumPy to build up your algorithm. But let's say for the typical application of raster environment, vector environment, we can do it with GDAL. Then there are also this one geographic network program for managed network, and the network are nothing else than vector with connection between points. That frankly speaking, I never use it. So I would like to have a bit of time to investigate it. So among these GDAL, there are plenty. When I started 20 years ago, there were only three: GDAL Translate, GDAL Inf, and GDAL1. But that's it. And then every year, an increasing. And quite often, I come back over here, and during the class, I discover a new one that I didn't see before. So let's see over here the most important one, and then maybe you can say a few words if you were using. So let's go with the GDAL Translate. So you arrive to here, and you have the typical bash command manual, okay, format, syntax. So that's why we were also stressing the importance of the bash syntax, because it's also used for GDAL tools. So you always have the command in front. Everything between square brackets is optional, and all of them, they start with a dash, or sometimes dash, like in this case. But most of them, they have only one, okay? So then you have between curly brackets, you have the option. So for example, this one is the typical resampling that can be nearest, bilinear, cubic. So these one are the typical one. So then you have different kind of flag. For example, you can crop based on X and Y dimension, but not X and Y dimension as a lat long, but as a number of row and number of cell, row and line, row and column, or by coordinates, okay? And also, for example, you can change, you can do scaling of the pixel inside. You can change the data type. Lonzu is going to explain very well this part in a few minutes. And over here, you have the input and output. Source, SRC stay for source, DST, destination, stay for destination. So you have always GDAL Translate command, input, output, and whatever is over here, they're flat. So it is a very well written manual. So try to go there. The beginning is quite hard to understanding and to figure out what you need, but try and make some inverse engineering, and I will show a really nice trick that we can do it as an example for using and understanding is what you do is correct. Okay. So the same for the other command. Let's pick up another one. Okay, some of you pick up one. So which one you were using, for example? Anyone was using one? Let's say I didn't know, and I was trying to do it in R and slowly. Then I come here and I was using which one? Okay.
I mean, I haven't used it in some time, but I remember that. Oh no, I cannot see the list of function in your screen. I don't know why.
Too small.
Oh. It's like there is a big square in front, but I can have a look myself. Well, just in general, GDAL translate, as you mentioned, and GDAL warp, I don't know, it's just like, it's so efficient. You can go in so many directions just with these functions.
Yeah.
And it's so much more stable than trying to do that on, oh, I can hear myself.
Okay, let me do it here.
Sorry. Okay. Yeah. So no, it just in general is just really nice because it feels it's much more stable and also faster than if I try to do it on Air or on ArcMap or I don't know, whatever. Because in the end of the day, as you said before, like actually most of the software they use GDAL internally, so why not just doing it directly? And that's something I learned actually from when I took the course in Matera. And I think that was really one of the parts that I like the most, where I progressed so fast because I had to deal at that point with IL photos that were very fine resolution and very heavy. And yeah, I had to find like ways to like convert them and do processing on it. And it was so much easier once I got to discover those functions. And I think, yeah, as I said, like, I think GDAL Translate and GDAL Warp are among the ones that sometimes I would just use it almost only that.
Yeah, yeah, very good. And in particular, GDAL warp is very
Giuseppe,
important. Yes,
we
please.
see a black square on screen. Do you see something special? It's a big square cover half the screen.
Not really. Let me stop the sharing.
That's a Zoom window. Like Zoom doesn't show the other Zoom windows. So I don't know if you had like the participant list or webcams or something, but then it appears.
Okay, okay, let me try again. Okay, we'll go sharing again. Okay, but better. Yeah, Rosalia said yes, so I think it's a yes for everybody. Okay, cool. So for GDAL warp, you have the warping of the image. I think many of you in GIS field has been dealing with reprojection information that sometimes are really tedious. You have to not only from heavy, but also especially if you're dealing with a local data set. Local, I mean country level data set that they have their own projection information, and you have to cross over with all the data set. They have lat long, like globally lat long UGS84 system. So the GDAL warp is really making your life not easy but faster, because then you have to deal with the troubleshooting and so to understand which one to use it and if it's overlapping fine and so on. So the same, you have the command with all the different flag. Be careful that sometimes, especially this one, the bounding box of your study area, sometimes they go, I don't know why they did it, but sometimes they this one is mentioned first X mean, and the other one is talking about upper left corner, so they invert the position of the extent. It's always a bit tedious to figure out. And then you have always a source and destination file, like in this case. So some other, like for example, proximity. This one was adding GDAL proximity. It was adding few, like 2-3 years ago. Before it was not there. Maybe a bit more. Maybe 3-4 years. The GDAL proximity is calculating from a point or from a road network the distance. Okay, so it's creating proximity from distance. Pay attention that some of the command have a .py extension, means that they are written in Python. So you can easily list. So this one I can close. You know. Yes. So you can easily list in your OS machine if you type a GDAL, and then you press twice tab. Okay, you get all the command that you have. So you can see immediately that some of them are in Python, and the one that they don't have anything are in C, directly in C. So the GDAL.py are a bit slower, but much faster than the other one. And the beauty that they are just Python script, so you can even open directly. So there is a command that say locate. So you can see where they have been installed. And this one is just you can open is a text file, is a Python script that you can open, and you can see it and see how they've been building up that file. So I use it quite a lot to get one command that maybe is very similar, but I want to adjust something, so I can modify this one. Of course, you have to have a bit of knowledge in Python to be a bit faster and so on. The same for perfect the same procedure. So feel free always to come back to the lecture and go and. So let me see. Oh, I was doing this in Python, or directly in Python, or maybe in R. Let me see how you address it inside GDAL, and you can find most of them over here. So the same for the vector programs are not so much. The most common one are OGR info and OGR to OGR. So these two really give you the information about the vector file, and this one for conversion of the vector, but also cropping, extend, cropping, extend, clipping, even some overlay, and some overlay also intersect. So it's quite handy also this one. So also here you have perfect the same syntax, and be careful about this. I want to point and stress you out. Over here, don't ask me why, but it is. Anyone can tell me something strange over here. Lonzo.
It's mostly green and with a little black in the end.
What? Can you see my screen?
Yeah, it's I can see now. Yeah.
Yeah. So what is strange over here for all of you guys in this command? And you can stay years in if you don't notice. So DST stay for
Destination.
Destination, and this one stay for
Source.
So they do the opposite. It's output input. Okay, so quite often we always work input first and then output second, but over here is the opposite. So be careful about, take a note, because it's and every time that I use OGR to OGR, I have to always remember that is the opposite. If not, that automatically you make a mistake. So pay attention about this. Okay, so let's go into the Jupyter Lab, but I think it's a good time to have a bit of break. So let's come back at 35. This way we have 15 minutes break, and then we progress. Okay, see you soon. Okay, so let's continue now with the GDAL application. In particular, we will see how to use it in a really simple way. But of course, later on you can combine all these commands. So I try to have a little example with a fast understanding. But then, as you can see, you have seen the flag are many. So, and the option that you can do with a different flag are also quite infinite, let's say many. And so it's a matter of try to understanding how to combine a different flag in order to achieve your goal. So let's see the most common one, the one that we use more, and see how we can proceed. So you can open directly I showed to you how to open directly the Jupyter notebook. So just to remind you, you can migrate inside to the you can migrate inside to the exercise and open the Jupyter Lab 01. Okay. So one of the good application interaction that GDAL is directly implemented inside to the bash environment. So we can have the combination of bash command and GDAL command all together for achieving some particular task. One of these, for example, is the list of all the teeth. So with a while character, we can easily list all the different teeth that we have in the inside to the geodata. Okay, we are working mainly with the file inside to geodata. So we will pick up a few of these and start to play and see what we can do. Something extremely important also, as soon even before to open a TIFF file, and in particular is to list the property, the metadata of the TIFF file, and this you can achieve it by running the GDAL info. So GDAL info is giving to you really the metadata of the file in terms of extent of your geographical location. Okay, over here, upper left corner, low left, and so on. So the 4 points in your tiles, you have all the different information about which kind of projection. So in this case, I'm working under WGS84, EPSG 4326. Anyone knows already this EPSG 4326? What is the EPSG?
Isn't that WGS 84?
Perfect. So the WGS 84 is, and not only the WGS 84, all the different projections are labeled by the EPSG code. Okay. So if you go in the spatial reference, yeah, this one. Yes, spatialreference.org. Okay, so if you click in this one, spatialreference.org, you have the list of, I use it quite a lot. I have the list of, there are the list of all the different projections in the world, and they can be related under they can be labeled under the EPSG code or under, if you go to the home, you can also see the other one, the, yes, it's the PSG code, and you can see also the S3 one, and you can see also the now it's not coming, the OGR, the other one, the OGR. So let me see if I all this. And the beauty is that, yeah, this is the other one, SR or G. The beauty of this platform, you can really even list it based on the data type, on the data product, Of course, they are not all of them. So if you're using, for example, WordClean, probably it's not over here, but you know that WordClean is using WGS84. But with the most common one, like Modis, Landsat, you can even check which one are the one that the Modis and Landsat are using. So when, or if you know already, in particular the PSG 4326, that is the one that is used at the global level, you can go directly and check the specification. So this is very important data site that I always suggest to store as a bookmark. In particular, over here you have the different file format that store the information about the projection. Okay, so so for example, you have the typical .prg file, that is the one that is associated with a shapefile. So if you click over here, you can open is a text file, and you have the typical, let me see if I can find a new application. Or application. Yeah, this is just a text file, so you can open even with the Emacs. Okay. Oh, no, maybe I don't save it. Or let me save it. I save it, and you can open directly. So it's going to be in the download, and it's going to be, yes, this one. So these are the typical PNG file that you have associated with the shape file, and it is a text file and has all the different information about the projection. Something also very handy that in this file, in this internet site, you can use it, the proj4. So the proj4 has the same meaning of this file over here, but is a string that you can use it in many software, including R, to define the projection, okay? So probably some of you was already using in R under the, quite often you do the CRS equal, and then you put the string, okay? So probably Marianne, people were using R, were using quite a lot this string to identify the projection inside a raster file or something. So this is the syntax for R for identify the projection. So in other words, use it this internet, this platform as a reference to pick up this string or this file that identify the projection in your file. So anyone was using already, for example, the proj4 string for your file and so on? Yeah. Okay. Cool. Anyway, over here it's good because you can over here Google it, Landsat, and you get all the different projection that Landsat was using, and you can come over here, get a PRG, and then copy paste inside to your scripting procedure. Okay. So these are the information that later on are translated inside here. Something also quite important to check from the GDAL info is the dimension of the matrix. So this, as you can see, is quite a small matrix, so it's going to be very good for testing. We talk when it starts to become more than 40,000 by 40,000. Over there, it starts to become quite heavy TIFF file to read about. To read and write and do operation. So another important information is this one, the origin, okay? That are really the origin, also the pixel size, okay? The pixel size is expressed in the same dimension of the reference system of the coordinates. So in this case, what is this? Anyone knows what is representing, how much it is, and anyone?
Were you highlighting the pixel size now?
Yes. What corresponds, where that number comes from, and how much it is?
Well, it's hard to tell because it's WGS84, right? So it's something in decimal degrees.
Perfect is in decimal degrees, but always try to keep in mind this relationship. So 120, sorry, 1 degree divided by 120, okay, is giving to you the 0.83, this number. And this number is more or less 1 kilometer at the equator, okay? So if you remember this operation, this operation, yes, this mathematical operation, 1 degree divided by 120 is 0.083, is 1 kilometer at the equator. And then from here, you can derive all the other. So of course, if this is going to be another zero, is going to be the so-called, is not really the 100 meter because it's becoming 90 meter. So is, for example, the merit, the digital elevation model merit is a 90 meter resolution. So, and if you divide the 90 meter divide by 3, you obtain the Landsat 30 meters. So this is where they come from, this number. So try to remember this relationship, and from there you can derive all the others. So it's quite often come back to this operation, and then I say, okay, if I multiply by 4, I obtain this. Yeah, the 0. This is not very common, but for example, this one is common. For example, that is so-called the 5 kilometer resolution. And something also quite important, especially for the massive TIFF integration, TIFF manipulation, is that try to be sure that your pixel size is not rounded at this way. So in other words, you want always, pixel size that are rounded, are not rounded, sorry, 0.8, 0. In other words, yes, 0.008. In other words, are not rounded. There are many, many, many trees. Okay, because if you start to have it surrounding situation like this one, or maybe like this, okay, with the 4, after the 3 you become 4. What is happening if you work with one file is not a big issue, but if you have many tiles and you are doing a big computation at global level, especially if your file are small, they become start to 90 meter. This little rounding through the time that, because it's always started from the upper left, so through the time that you go up and down to the right is accumulating, and then you can have 1 pixel or 2 pixel shift in the last tiles. Okay, so with GDAL edit, I will stress to have this kind of rounding always full, and more you put it, better it is. Okay, and especially people that are coming from R and they have output from R, or if they downloaded TIFF files like the Chelsea, yes, the Chelsea data set that are computed in R. These are always rounded. Okay, so these are always rounded like this, so they are truncated, or they become 0, or they become to the next, to the rounded to the next upper level. So it's very annoying if you are working with big tiles, with many tiles and at global level, because then this little change, you will not see the difference. And in the same way that you have to have over here 3333, also here you have to have the integer value. So the same, if you have an extent that is something like this, okay, try to correct, because if not, later on this error is carry over, and sooner or later you will have a shift that you sometimes it's not neither easy to check to understand where it is, because you cannot check pixel by pixel. So rather, if you have always your crop at degree level, so at this way and not something like this, then this is also fine, but sometimes it's better to really crop at degree level. So when you go, this is for the global implementation. I mean, global implementation working a lot long, but it's perfect the same in UTM. So in UTM, you will have the huge number, something like this, and not with 1 meter shift. Okay, so pay attention to this, and sometimes this one, for example, this is a good example. So the upper left over here is telling us, that is ending at 4. But if you check the origin, and the origin, you have the beauty of this, that is a bit longer the number. You can see that you have a value 4 over here. Rather over here, you don't see. What is happening that now this one is influenced by the rounding of this one. So with the GDAL edit, you can correct this kind of small shift. And again, it will be extremely important to have a tiling mosaic without gap and without overlapping pixel, and really precise way. Many people, they don't realize, but when you start working with GDAL and PK tools and also in grass in a very intense way, you want this kind of precision, because if not, they come up with additional error later on, especially when you cross over different files. So again, if you're working with one image, it's not a big deal, okay? But if you start working with a combination, a mosaicing of image or raster file, digital elevation model that come in different types, you want to be sure that the file are like this. And if you get it, just modify this, and we will see how. Just modify this one, round it to 333 in this case. Your data set is not going to be shifted or anything, because if you think it's just at this level, probably is maybe 1 centimeter if you do the math. So it's very small fraction that will not influence it, the pixel per se, but will influence the full computation if you don't do it. So pay attention about this. Something also very important, and I will also stress it a lot, is this information, the data type, and we will have Zu go through the lecture on this, and also the no data value. Okay, so so when you have a good understanding of the metadata, at this point you can open the image. Okay, so over here we have been installed the OpenEV, and if you want, you can go in the first lecture. There was a script that we ran to install it, this additional software. So you can go back in that script and see how we install it if you want to install it in another machine. OpenEV is very old-fashioned software. You can see now it's popping up. It's very old-fashioned in terms of, it's not a real GIS, it's a more visualization viewer of the image. You cannot do it fancy GIS, but it's very fast. You know, you have a bit of rendering and color stretching over here that you can play. You can zoom in and zoom out quite fast. Okay, and over here you can also have a bit of graphical interface if you want to do some changing coordinate. For example, this one is helping you. So when you move over here, the beauty that you have the coordinates and also the pixel value without clicking. So it's very good to understand what is going on. So you have the coordinates and the pixel value. And also over here, if you can change the preference rather than your reference, you can do raster pixel line. So you will have over here down this area, you will have the row and column of your matrix. So it's very good. Okay, you want to go here and you say, okay, let me take a note of this pixel because I need to do something that pixel. So it's very good for this kind of application. And then of course you can close it. Be careful when, okay, here now I need, it's popping up this other window and you need to close it all together. Something very important is also that you can open many images. Okay, so and this is very very handy because it's popping up. As you can see, I'm in the virtual machine. I open up like 20, a bit less, 10 image, and over here you can go one by one, and you can, yeah, they are very similar, so you don't see because they were, but over here you can see that I'm changing. Okay, so you can also open RGB file or Landsat image with multiband. It's quite fast. You can open also remotely. So that's why we use it quite a lot for fast checking. And in the same way that I use the asterisk, you know, you can open a full mosaic. Quite often I work in the high performance computing, and I have the teeth that are coming out. I open it, and even remotely. Okay, if your internet connection is good and you are close by, I am in the same city where is the machine, the HPC over here, so I can open in my laptop. If not, you need to download it and then open it. But at least you have a fast rendering. So I use it quite a lot for this kind of data exploration. Let me check, you have the feeling and so on. So feel free to open. We will open several times and start to use it also for your application. Is anyone who's using already OpenEV? No? So if you try to do the same now, the same operation with the QGIS, probably don't want to do it because if not, it will take. So if you do just change over here QGIS rather than this one, you will see that will take a time to uploading everything. So I use it really for this kind of fast check. Again, you cannot do it fancy map, but you can do this kind of fast rendering and so on. So I use it to open, if there are locally in your machine, you can open 2-3 gigabytes of TIFF file without problem. They have an internal machine, an internal system of tiling. So you can zoom in, zoom out. Of course, the zoom in, zoom out, big 2 giga will be a bit slower, but much faster than QGIS. So it's also good for the virtual machine that is not very heavy and so on. Okay, so this is for the visualization. And now we move towards the understanding better the data. And in particular, something extremely important that Lonzo will kick in with his lecture is the data type of the TIFF file. And the data type in general is going to be behind any kind of computation and mathematical computation. So it's extremely good to have it in mind, this table. And after a while that I was working, actually this is a table that is coming from GRASS, that is r.out GDAL. So also GRASS is using GDAL as an engine to pull and to import export data. And they have this nice table that represented the data type in the GDAL format and also in the GeoTIFF format. Okay, so I was very happy because I finally have a table that I actually print and can tell me where are the data range and of each single data type. So the byte, for example, go from 0 to 255. The unsigned, U stay for an unsigned 16 byte, go from 0 to 65,000. And if you have the int, if you have the int, you can go directly. You can go directly to the. You can go directly to the same range, but you can have the negative. Okay, so you can go from minus 30,000 to plus 30,000, and so on for the order. Okay, pay attention that why is important to understand the data type and working properly, because every time that you increase the data type, your image becomes larger and larger. Okay, and this range is going to be important to store your data set. So if you are storing land cover and you have 10 classes, the best option is to use from 0 to 25 because you have 10 numbers. So it's going to be included. If you have a digital elevation model that goes from minus 400 something in Death Valley until 8,000 meter in Everest, so you can use this one because it goes from the include, the minus 400 plus 8,000, and so on for the others. Pay attention about when you go down, is the integer becoming very long. So even what is happening that even if you store number 2, okay, is going to have all the space for these long numbers. So your image, even if they are the same land cover, but if you change the data type, is going to be become larger. So pay attention about if you go from here to down, here, what is happening that everything that is larger. So if I go Everest, let's say, Everest is inside here, I save to byte. So everything that is larger or smaller, in this case, smaller than 0, bigger than 255, will be truncated and will be assigned the 255 or the 0. Okay, and quite often what is happening that the node data is stored as the extreme of this value, and not as the extreme, as the final one of this data. Okay, so for example, it's quite common to see the node data as minus 32,000. Okay, or as plus 32,000. So have you encountered in this node data as this number? And now, did you understand where they come from, this number? And some of you knew already about this data type and so on. And now you can see, okay, now I get it. Now I get it why every time I convert to data type, something disappears. Okay. So pay attention about this. Okay. So in order to understanding where all this data come from, all this data come from this extreme external range. I give give the words to Lonzu that is starting his lecture, and in particular we are going to addressing this lecture, but please don't click in this link, but go back into the virtual machine and sorry, not in the virtual machine, in the OSGeo Live, click in the GDAL OGR that we are, and then scrolling down in the same position and click this, because this is the right link for the lecture of Lonzo. Okay, so again, GDAL OGR, and then it's the same web page, and then you click and you have the lecture of Lonzo ready to go. And in particular, it's going to focus on where this number comes from, the different data type, numerical system implemented, not only from an IBAN point of view, but also from a practical life and also computer life. Okay, Lonzo, the floor to you. I stop sharing.